Hello everyone, welcome to my YouTube channel MK Maths. In previous video we have discussed about this definition of relation and types of relation. Whoever still not watched that video, please check my description. I have kept that link of previous video so that you can press that link and watch this previous video, definition of relation and types of relation. So if you understand this definition of relation and types of relation, then it will be easy to understand next further concepts. Okay, so before going to explain types of relation, one point we have to understand the representation of a relation. Here in representation of a set we have studied in a first view. In first view we have studied this representation of a set. In same way here we are representing relation now. So there are three ways to represent a relation. So first way we named it as a roster form or tabular form. Roster form or tabular form means here we are representing in with order pairs. So 1, 3. One order pair means in previous video we have already discussed ordered pair is nothing but 1 is related to 3. Here ordered pair 2, 4 means 2 is related to 4. Ordered pair 3, 5 means 3 is related to 5. Okay, so we are representing a ordered pairs. We are representing relation R in ordered pairs, so that form we call it as a roster form. Same relation we are representing in set builder form. This is called as set builder form. So this is in a set builder form means, so we build here as some set. So using general way representing a order pair A comma B, and here we representing what is the relationship between A and B. We not explained any elements of A and any elements of B, but just we are expressing relationship between A and B. Here the relationship is A plus 2 equals to B. If we consider a element from the set A, if we add 2 we get a 3 that in set B. Okay, so relationship between A and B, the R representing a relationship between A and B. Here the particular relation is we have to add 2 for each and every element of A. So if we consider a small a is the element of set A and small b is the element of set B, then if we add a 2, A plus 2, if we consider A plus 2, we get a value B. We represent it as a B. So here we have created this set by using this single common property. We call it as a single common property. Single common property means every element of A and B which satisfies this single common property, then that form of R is nothing but a set builder form. In examples, either we get a roster form or a set builder form. In any way we can represent the relation. Both are same. So both are equivalent, actually both are same. So we can represent R by using ordered pairs 1, 3, 2, 4, 3, 5, or we can represent the same relation R by using single common property A plus 2 equals to B. Okay, so there is another one representation of a set. There is another one representation. This is nothing but arrow diagram. We call it as arrow diagram. So by using arrows we represent a relationship between A and B. So here I considered A, set A has a 1, 2, 3 and B has a 3, 4, 5. Okay, so 1 is related to 3 because we are adding here. The relationship is here A plus 2 equals to B. We have to add elements of A 2. We have to add 2 for elements of A and we get a values in B. So we representing this relationship using this arrow mark. Okay, so 1 is related to 3, so we are writing a arrow diagram for 1, 9, 3. 2 is related to 4, so here we are representing a arrow mark for 2, 4. 3 is related to 5, we are representing a arrow mark for 3 to 4 by representing this relation or using arrows. So we call it as a arrow diagram. So we have 3 forms to represent a relation: roster form, set builder form, arrow form. These three are also important to understand types of relation. Next, okay, so now let us come to our first type, empty relation. So this is empty relation. This comes under trivial relations. This comes under trivial relations. Trivial relations means, in previous video we have already discussed, it is obvious thing to represent a relation, obvious thing to create a type of a relation, empty relation. So what it defines means, so here same, I have considered the R. If R is said to be empty relation, in set A, I have considered only one set, because for some types we use only one set, because we can use two sets, A to B also, but here for simplicity we are using only single set, A to A. We are defining a relation, for each set A itself only. So for simplicity we are using single set here. We maybe say that if R is said to be empty relation in set B, if R is said to be empty relation in set C, anything we can say, but here we are mentioning only one set A. Actually, in previous video definition of a relation we have all mentioned A to B. Okay, when it comes to type of a relation, we, for the simplicity sake, we use only single set. Both are same. A to B is also same, A to A is also same. We are just defining a relation from where to where. So here, from relation start with set A and end with set A. That's it. So if R is said to be empty relation in set A, then the condition is no elements of A is related to any element of A. If you consider any element of A which is not related to any element of A itself, means there is no relation in between themselves. If there is no relation in between themselves, we represent that set R equals to empty, because there is no relation between A itself. So if R is empty, we already know empty set is always a subset of any set. So here empty set is a subset of A cross A. By using definition of relation, this is nothing but definition of relation. In definition of relation, we have mentioned if R is said to be relation from A to B, then R must be subset of A cross B. Here, in similar way, here we got a relation empty. So this empty set is a subset of A cross A. If empty set is a subset of A cross A, then obviously we can say this empty set is a relation. So that empty set is nothing but a empty relation. So here R is empty relation in set A, because that R has no relation created in between set A itself. So there is no relation. So let us understand with the example. Okay, so in here example, I have took two examples, in general way and in mathematical way, in mathematics. Okay, in general, if I consider a boys school, see here, if I have considered here boys school, just for example, in general, in boys schools, I am asking to create a sister relation between boys. So it is not possible. Sister relation is a relation. Okay, we can't say it is not a relation. Sister relation is a one relation, but sister relation in between boys school. So here given condition is a boys school. So this sister relation in boys school is not working. So here the relation will be empty, because sister relation is not possible in boys school. So here that R is empty. We can't create a sister relationship between boys. So here R is empty. So here R is empty means this is empty relation. Okay, so this is the general way to understand empty relation. Means for given condition, if this relation is not satisfying at particular given condition, then that relation will become a empty relation. Maybe that sister relation is a relation. We can't say it is not a relation, but that sister relation is not working in our given condition. So then that relation becomes empty relation. Okay, so in mathematics, let's see some example. So if I consider A 1 2 3, if I consider a set A 1 2 3 and I create a R here, I create a R, so ordered pair A comma B such that A minus B equals to 5. A minus B equals to 5 for all A comma B belongs to A. For all A comma B belongs to A. This R I have created now. This R is nothing but this is representation of, in previous I have already discussed, this R is in now set builder form. Okay, set builder form. So these forms already we studied in first view in sets chapter. Okay, now here this set R is in set builder form, and in this set R there is a relationship between A B, or because I represented as a ordered pair A comma B. The relationship is, if we subtract two numbers, from set A, we should get the answer 5. So this is the relation. Take any two numbers in set A and subtract. If we get a 5, then if we subtract two numbers, if we got a 5, means there is a relationship between A and B. If you consider any two numbers and subtract, if we got a answer 5, then there is a relationship between A and B. Okay, we can say like that. So here A, for this symbol is nothing but for all, and this symbol is nothing but belongs to. In first P we have studied belongs to means those elements which contains in set A. For all means every element. We should not miss any element. We should consider every element of A. Every element of A here is 1. We have to consider 2. We have to consider 3. We have to consider. We have to use 1, 2, 3. These three numbers we have to use to create this relation. But if you observe here, it is not possible. So if I consider 1, 2, okay, 1 minus 2 which is not equals to 5. If I consider 2, 3, 2 minus 3 which is not equals to 5. If I consider 3, 1, 3 minus 1 which is not equals to 5. So 2, 1, 2 minus 1 which is not equals to 5. Next 3, 2, 3 minus 2 which is not equals to 5. Next 3 minus 1 which is not equals to 5. If we take any two numbers in this 1, 2, 3, we have three elements. We have to consider every element of A. If we take any two elements and if we subtract between those two elements, we won't get a here 5. So it means it is a empty relation. We can conclude that here R is empty. Here R is empty because this is a relation. Subtracting between two numbers we should get 5. All this is a relation, but this relation is not working in A, not working in given set A. So we can say that this is empty. Then this R is empty relation in set A. Is empty relation in set way. In general way we have studied. In general way, if you consider boys school, then sister relation is a empty relation. If we consider in mathematics, if we consider a set A 1 2 3 and relation is A minus B equals to 5, it is also empty relation because there is no such elements which satisfies this condition A minus B equals to 5. So if there is no such elements, if satisfies this condition, means definitely we can say it is a empty relation. Okay, empty relation is nothing but the given relation which is not working for a given set. If given relation is not working for a given set, then definitely we can say that it has a empty relation. I hope you all understand up to here empty relation. In next video, let us understand about the universal relation. So up to now I have discussed about the empty relation. In same way, in next video let us understand the universal relation. So watch this video. If you like this video, please subscribe to my YouTube channel, and also don't forget to like my videos, because if you like my videos, then definitely it boosts the YouTube algorithm and it reaches a larger audience. So let's meet you in next video. Tata, bye bye.